So Pat, we're here today to look at a lagoon there that you've built. Your business Geoline, could you tell us a bit about it?
Yeah, the company itself was formed 35 years ago. We mainly started off doing industrial works where we had lagoons for chemical companies, general business. Then we kind of sold the idea to the Department of Agriculture that a lined lagoon would be a good way and a kind of a cost-effective way of storing agricultural slurry. So the business then gradually went into the agriculture sector, and for lots of years we depended heavily on agriculture. And at the same time then the general industry was growing too at the same time. That has kind of changed in recent years, and the agriculture has become lesser part of what we do, and more general industry now takes up more of our time. The agricultural window kind of is a small window between maybe April and September every year, and so we put in the lagoons at that period along with everything else we do then in general industry.
Okay. So say for farmers that are inquiring and ringing, say what are they looking for, say typically, what are their needs typically? Or
Yeah, so most farmers that ring me, their initial thing is that they need storage. In the current systems that they have, be it a combination of slatted tanks or above ground towers, they're still short on storage capacity due to the numbers that they have. So they're kind of, a lot of the farmers are on leased land. They're kind of looking for a cost-effective system that mightn't cost the world, and that they may have to abandon in 15 years' time or whatever. So that's why lagoons are an option for them. And mostly those guys now are looking for the bigger volumes, and the smaller lagoon is probably not that existent anymore.
okay, so what sizes typically are people looking at?
Mainly starting off now at 500,000 gallons upwards, and you know the sky is the limit. The other day there was one for 4.4 million gallons, so it's wherever, anything in between really.
And is that across all farming systems? Is it dairy, pig, or what?
Oh, just dairy mainly.
Yeah.
Yeah. We get the odd pig-related one. Sometimes it's a replacement from maybe a current system that they might have or something for pig, but mainly dairy.
Okay. And so when a farmer does decide to go ahead, say, or when you go to your initial visit, what do you look at, or what do you go through with the farmer?
Yeah, first of all, we look at the site. So in this case, when I met the farmer on this site, we looked at the site, the contours of the site, and to see exactly what way a lagoon would fit in. Some sites are dead flat, and this particular site is on a sloping site. So this one in particular suited the construction method that we've done here with the built-up embankments, which meant no material was drawn off site. Everything that was dug out of the hole was reused to form the embankments. So I get the farmer's view on where he wants it, what will work best for him, so that we're not using up land in a way that maybe makes it awkward for him to use the field. Then also we have to kind of bear in mind the layout of the farmyard and how they're going to get slurry to the lagoon. So in a lot of cases, farmers may well be scraping the slurry in over the top still, and so we have no choice but to put the lagoon along the edge of the yard, maybe in front of the sheds. Other cases, they can locate the lagoon totally out in a land bank where they may be drawing the slurry from maybe a catchment tank in the yard out to the fields and putting in a lagoon. So once it's agreed the location of where the slurry pit is or where the slurry lagoon is going, what happens next then is we mark it out on site. Obviously I'll get drawings done up and everything to match the lagoon. Come to site, mark it out. Our civils crew will come on the same day. Basically we get going on bulk excavation.
Very good, yeah. So on a situation like this is a tillage farm, and it's possibly taking in pig slurry or maybe waste material, and it's possibly something you'll see more of as well going forward, with maybe a better emphasis on using slurry as a fertiliser and stuff like that.
Yeah, there's a lot of lagoons now being built for that purpose, and a lot of lagoons taking in brewery waste and things like that as well. Okay. And it's particularly high in whatever nitrogens and whatever that each particular waste contains. So it's quite common for us now to get inquiries like that, and it's put in the middle of a land bank. An umbilical system is used to spread all around it, and it seems to be the most efficient way of doing it. So yeah.
And say just maybe going through this particular project here, what size is this lagoon here?
Yeah, this lagoon is a 500,000 gallon storage. So walking around the top of it, we're looking at a 30 metre by 30 metre measurement. It's 3.6 metres deep, so 12 foot deep. And this lagoon is, if this was in a dairy application, we'd be saying to size up your lagoon for dairy, allow about 3,500 gallons per adult animal. and then you work out the size capacity that you need.
Okay.
This lagoon is slightly different in that it's taking effluents and waste products and stuff like that, and it's out in the middle of a land bank. So this one is sized based on a known quantity that the client was going to store.
Okay. And so as we're looking at the finished product here, there's tyres as well. What's the purpose of tyres?
Yeah, the tyres are a safety measure. Again, referring back to S126, which is the department standard for lagoons, you have to have a tyre ladder every 8 metres around the perimeter of the lagoon. Mainly it's for, if wildlife happen to get in, at least they have a method of escaping. The same for a person or something. If for some reason they had a reason to be between the fence line and the lagoon and they slipped in, they can grab onto a tyre and pull themselves out of it.
Okay.
So hopefully never needed, but they're there.
And in this one you've one access point then?
Yeah, so in a square lagoon like this, up to 500,000 gallons, we're comfortable that one mixing point is sufficient. If this was 500,000 gallons and it was more rectangular, you may well end up with 2 mixing points.
Yeah.
We find a mixing point will give us a kind of an agitation diameter of about 30 metres. So anywhere in the middle of any one side here was perfect for it.
And the type of agitator, is that the one that goes in at the
Yeah, the whisk. Yeah.
Okay.
And a lot of the whisks these days, some of them come with an auger on the shaft, which drives the crust down to the blades. That's quite a good one.
Okay. So the fence as well, you look after the fence?
Yeah,
as well,
we look after everything, basically from digging right through to the fencing out, because we have to sign it off at the end. So the fence, the requirement on the fence, it has to be 1.8 metres high, so 6 foot high, and it has to be of a certain spec. So in this particular case, it's a 3-inch galvanised tubing, 4 strands of bull wire, 1.8 metre high chain link fence, and then a final row of barbed wire across the top to comply.
Yeah. And say indicative cost for somebody with 500,000 gallons, roughly what is?
Yeah, in the last 12 months, due to COVID and everything, things have risen a bit. So at the moment, you're kind of looking at about €55,000 plus the VAT for 500,000 gallons.
Okay. And going to $1 million then, say, roughly, or how?
Yeah, you could go up to maybe close on 80,000, depending on the shape and the number of mixing points.
Yeah, okay, very good. No, that's perfect. So we have some footage of the construction process, okay. So we might just go through that we gathered earlier in the year and just go through, I think, for people just to see how actually was this constructed and the various methods you used to make it all come together.
No problem. Okay.
So Pat, we have drone footage here now, say, of early days into the construction. Can you describe what's
yeah, so we're in the middle of the bulk dig there at the moment. So because it's a sloping site, a lot of the material that's dug out of one side mainly is deposited then on 3 of the other sides. And that then is tracked in layers, much like a lasagna. So every 300 mil, the track machine will track across it, tighten up everything, and eventually laser level the top of the lagoon down so that all 4 sides are dead level eventually when he gets around to meet himself on the other corner.
Okay, so this site here, you can see there's good gravity material in there.
Yeah.
If this was in some other part of the country and you had water coming at you again, or what, how do you handle that site?
Yeah, water is a difficult one. We try to, in early days, during my initial site visit, I asked the farmer if there is a water issue, if he thinks that we're going to hit a water table issue, maybe at 3.6 metres deep. If there is a big water issue there, sometimes we'll actually tell him straight out that the lagoon isn't suitable for that site. But most times we can incorporate the underfloor drainage system to take the groundwater out from underneath the lagoon and dig a drain down the field and get that groundwater off to a nearby ditch.
Right.
And that takes care of the uplift pressure from groundwater, because we have to avoid that. The types of soil that we encounter on some sites, where we hit shale, we hit limestone, all sorts. Everything can be worked with. We just have to be able to put a smooth surface on it. So basically, with the gravel material that we see on this site, that was a very good material and a very free draining material. So that was easy to work with. All we needed to do then was to make that smooth. So what we're seeing now in the footage is the pea gravel being delivered to site. So once the lagoon is fully shaped, the leak detection system is inserted into the floor of the lagoon. And what we need to do then is cover the floor of the lagoon in 75 mil deep of a 10 mil round washed pea gravel. And that basically is a drainage media. So any possible groundwaters or whatever that might gather underneath the lagoon liner, or if in the event that something happened to the lagoon liner and there was a catastrophe and something failed, that drainage media will bring either the groundwater or the effluent to the leak detection system underneath the lagoon, where then you will pick it up in the leak detection manhole outside the fence that we looked at.
And if you didn't put in that material?
You have to put it in, because otherwise the liner will stick to the base, and the groundwater or the effluent may not get to the leak detection system.
Okay, what depth of?
3 inches deep, so 75 mil of it.
Yeah. So now we're seeing here.
Yeah, so before the plastic gets laid then on the 4 sloping sides, we save some of the topsoil from the initial strip of the site, and we grade that to make sure that there's no stones in it. And we put topsoil on all the 4 side slopes, make it smooth with the back of the grading bucket on the track machine, and then it's ready for the plastic to be laid.
Okay, so now you have the plastic laid here. What was involved with that?
Yeah, so what we do, we bring a frame to site, which is a liner deployment frame that connects onto the boom of the excavator. The roll of liner itself is 7.5 meters wide and weighs 1.5 tons. So the excavator will attach the frame with the roll on it, lift it up in the air, and our guys then will manually pull strips of liner off the frame. So we try to generally go from one slope right across the floor up the other slope with one full sheet. And then once that's cut and put in place, we do the same with the next sheet beside it. 2 sheets are then overlapped by about 6 inches, and then that allows us to start the automatic welding machine to weld the sheets together.
What width are the sheets?
7.5 meters.
Okay, so what we're looking at here is the outlet point here.
Yeah, that's the outlet. That's a sump in the floor. So the sump is about 2 foot deeper than the floor of the lagoon itself, and the lagoon is sloping towards that sump end. So everything drains to that point. So what we're looking at is a pipe coming up through the floor, and that will be cut off at a later stage down lower than what you're seeing there at the moment. And that pipe is welded to the floor liner, and we've created a kind of a dished area in the floor to create the sump. And the liner follows the contours of that dished area. And what we see at the moment there is one of my guys welding the liner. It's a kind of a hand welding process at that point. So when you get away from straight lines with the automatic welding machine, you have to use a hand welding process.
Okay, so what are we seeing here now in this next part?
So again, this guy now, there's overlapping panels. That's in the corner of a lagoon where you'd have straight sheets coming down, meeting each other, and one sheet will overlap the other. So what we have to try and create is an even 6-inch overlap on the sheets of liner. So he's trimming off any excess material before he pops in the automatic welding machine. And there he is now. So he's after clamping in the automatic welding machine now on the overlap seam. And
is this a heat process or what is it?
Yeah, it's a heat process. So basically the machine itself is melting the plastic, the underside of one sheet and the top side of the other sheet. And then as the welder passes over it, it fuses the 2 molten plastic sheets together. And in the centre, there's an air channel, which we'll use later on for testing to make sure that the weld was completed successfully.
And this is self-propelled as such, is it?
Self-propelled, yeah. Yeah, okay. All the guy with it has to do is he cleans the liner in front. You see him doing that with the rag there now, and he just steers the machine to make sure it's keeping on line. Okay, so here now what the man is doing, we have 2 different weld seams coming in at 90 degrees to each other, and both of those weld seams were completed with the automatic welding machine. So because they're at 90 degrees to each other, that particular machine won't bond the 2 of them at that T-junction. So what we have to do is we have to prepare the material, grind up with a hand grinder, grind off the shiny surface off the plastic itself, and we have to use a hand welding technique then to make a T-joint at that particular point. So you'll probably see that come up later. There he is now with the hand welding machine. So what we see is a rod of plastic coming through the welder, and as it passes through the welder, it's heated up to about 230 degrees Celsius, and it comes out the bottom of the welding machine as a molten plastic. Similarly, in this footage, he's using the same technique to weld the floor liner to the pipe that's coming up through the floor. And again, the pipe is made of the same material as the lagoon liner itself.
And this here, what's he doing with this?
So that's the testing. So before he completed that weld, he put a copper wire filament into the the joint between the pipe and the floor liner, and then he extruded the plastic over that copper filament. So now with that machine there, he's pumping electricity into the weld seam, and if there's any defect whatsoever in that weld seam, a spark of what looks like lightning will pop out of the point where there's a defect. And if that did happen, we have to re-prepare that area again and re-weld it and then retest again.
Okay, and this pipe here there where he's hand on, do you cut that to the floor? How
yeah,
do you leave it?
Probably in this case it was probably cut down about another foot lower than what you see it there in that footage. You could go straight to the floor if you wanted to. Some cases just best to leave it up a bit so you can leave some silt gather at the bottom of it. Yeah. So this is the second test method then. So with the automatic weld seam, there's an air channel in the centre of it. So you see on the picture the mark of 2 wheels. So that's a weld seam underneath each wheel, and in between there's an open air channel. So what we do is we block both ends of the air channel with some extrusion weld like you seen on the previous welding machine, and we pump air into it. We pump that in at about 3 bar, and you leave it for about 5 minutes. Monitor the pressure gauge the whole time. And if your pressure remains stable and there's no drop in it, that proves then that the weld seam is intact and that it's not going to fail. We also do mechanical testing of it. So in the anchor trench, we might cut a little tab out of the weld seam, and we put it in a machine and actually pull the weld seam apart. And what we're looking for there is that the liner itself will fail before the weld. So the more welds there is in a lagoon, the stronger the lagoon will be. The weld seam is the strongest part of it. So the lads are marking the pressure. You see they have 3.8 bar pumped up there, and the time frame as well as to how many minutes they left to test on for.
So in terms of your process of construction on the civil side, do you do the civil side or do you subcontract that, or what aspect of that do you do?
Yeah, Geoline have to control everything from start to finish because we have to sign off the job at the very end. So I use the one civil company all the time. Dial and Sons, you see them on the machine there. They come with me to all the lagoons, and he is technically a subcontractor to us, but he does all his work for us. So
what are they doing there then?
So what we're seeing there now is the lagoon liner is in, the testing has been done, the seams are passed off, so now it's okay to backfill the anchor trench, because around the top of every lagoon there's an anchor trench that the plastic liner has to pop into, and that's about 600 mil deep. So he's filling in that now with the soil to stop any wind taking away the liner out of the lagoon and to tighten up the liner in the lagoon.
So we're looking here at the lagoon. There is some material that's been dropped in, but say your tyres there at the end, there's one is filled with concrete at the end on each of them. Why is that? Yeah,
the main reason for the concrete is to keep the tyre ladder in place. So particularly during agitation, the tyres would have a tendency to move due to the motion of the liquid when it's been agitated. So having the bottom concrete tyre filled helps keep the ladder exactly in place, and it's just a safer method, and it also prevents people from pulling them out.
So an obvious question from farmers or whatever is managing rainfall on say lagoons or whatever.
Yeah.
So do you have covers for it, or are they practical, or what do you see in practice?
Yeah, we have 2 cover systems available. One of them is a complete cover, but it does depend on how you control your farming practices to actually get the liquid in and out of the lagoon. So the complete cover will mean that you won't get a drop of rainwater in there, but it does mean that you have to probably use an aeration system to agitate the slurry underneath, and you have to suck all your liquid in and out through a side slope riser pipe. That doesn't suit all farms, and particularly open farmyards where you're dependent on scraping in over the top. That won't suit it. The second cover, we have a cover which basically we're trying to develop it to kind of satisfy the department requirements on emissions and stuff. So what it does, it covers about 75% of the open area of the lagoon, and it's on a kind of an elasticated bungee cord system, so it floats up and down with the level of the liquid in the lagoon. It satisfies the purpose of reducing the emissions, but it doesn't stop any rain getting in, and then you will still have the perimeter which is exposed. I mean, our thought on it is that the crust on the slurry itself is nearly a better seal than any of these covers. In reality, I just have the slight little worry that covers, particularly the one that's on the bungee cord system, may not be a fully safe system, and if they would maybe not put in that cover system, maybe the department, it might be a better thing for the department to kind of consider, you know.
Yeah, and I think it's fair to say that the department as well, and their views recently I've heard, is they're more concerned about keeping the wind directly off the surface of the lagoon as opposed to the rainfall going in. So it's trying to create a barrier or say an embankment around the top of the lagoon to keep the direct wind off it, which is which is a lot easier to construct as opposed to putting in a cover.
Definitely, and we're going to have in a lot of cases we have excess soil created, particularly in lagoons that are built on flat land. There's lots of soil left over, so if we can create some sort of a mounding around it with some of that soil, it's good, you know.
Yeah, yeah. So it's a practical. There are practical solutions to solving that.
Yeah.
So Pat, with the lagoon here and the height advantage that you had above, one option here obviously is for the tanks or biblical system, say, to pull up here, and for the farmer to connect here. Could you describe what we're looking at here?
Yeah, so basically this is the outlet point for the lagoon itself. So we have a pipe in the floor of the lagoon, which is basically allowing that lagoon to totally drain down so that there's absolutely no liquid left in it. Gravity will force the slurry from the lagoon to this point, and what we're looking at here then is a triple valve system. So basically we have two standard slurry knife valves, and they would normally be in service on a full-time basis, so you have dual protection, and then we have a third valve beside it, and the idea of that valve is that you can tighten down that valve and replace out any of the other two knife valves, if ever any of them fail in the future. So the tanker then, or the umbilical system or the pump, would just connect onto that, the bower end, open the knife valves, and gravity is just pushing the slurry straight out to the system straight away. No diesel really used to suck slurry up out of a deep lagoon or anything, so it's an efficient way of doing it. Yeah,
to probably fill a tank too if you had a...
Yeah.
Okay, so the wall, what does that do?
The wall is really just holding everything in place. It's just a kind of a head wall just for stability. And then we have a kind of a resting plate underneath it as well. There's a concrete slab on the base there, resting plate on it that stops the valve system is cantilevered out, so we stop it from waving around.
Okay. Would you do, say, a solution like this on many of your jobs?
Probably about 20% of the lagoons put them in. It doesn't suit every land because it suits this property great because it's on a slope, and then you're using the natural slope to get the gravity line working for you. If you're on a flat field, it wouldn't work as well, really. So they don't tend to put them on.
So what size pipe then is feeding from the lagoon?
So it's a 6-inch pipe or a 150 diameter pipe, and they're all 6-inch valves. They're all mainly termed in imperial measurements 6-inch as such. So, and that then matches up with the connection points on the tankers and the pumps. So we keep it matching.
Okay, and is that a solid pipe from here to the lagoon?
It's a fully welded, so the pipe that you see, that black pipe, it's a polyethylene pipe, high density polyethylene pipe. That's the same material that the liner in the lagoon is made of. So when that pipe then, it's welded in 12-metre sections, and when it comes into the lagoon, we weld the pipe to the lagoon liner. So there's no possibility whatsoever that the leak can happen at that point.
Okay, great, perfect. Pat, what are we looking at here in the manhole?
Yeah, this is the leak detection manhole. Part of the requirements from the department with the S126 specification is that you must have a leak detection manhole. So the council or any state body, anybody at all can come, lift the manhole cover, take a sample of the liquid in the bottom of the manhole and take it off for testing. And the idea is to prove that the lagoon itself isn't leaking, and that any liquid that's under there would only be groundwater and not contaminated with anything. So that's the main purpose of it.
So on the design here, when you designed it, everything is draining back to this point here?
Yeah, so the leak detection system in the floor of the lagoon all comes back to an extract pipe which comes through the embankment, and when you lift that cover, there's a vertical shaft manhole going down, and that pipe connects into that manhole. And then there's a further 1 metre drop below that again, which is all filled with groundwater or whatever liquid that might come in there from the ground itself.
Yeah, perfect, great. So Pat, we're up on the bank here now, and looking back down, say at the output below, there's a significant height difference. Roughly what is there?
There's about 3.3 metres in the difference of the lagoon floor. Say the lagoon floor and that pipe are roughly equal, maybe 300 mil in the difference, and then where we're standing, 3.3 metres difference in height. So you have that much head of pressure then forcing the slurry down to that point.
Yeah, very good. And that's great. And significant pressure then on the... for the filling.
Yeah, I mean you can completely drain the lagoon from that point and gravity does the work for you.
Yeah. So Pat, in terms of, people are going to look at concrete or they're going to look at plastic lined lagoons and they're going to ask about durability. What's the lifespan on this, or say guarantees can you give?
Yeah, well, the Department of Agriculture require us to give a 30-year guarantee on it. That's a minimum. The lifespan of that material itself, the manufacturers at the moment will say they'll definitely stand over 50 years plus. In reality, they reckon 300 years is the lifespan of that material. It's just unaffected by anything. Even in the chemical industry, it's unaffected by most chemicals.
I suppose what we see in our design services, we're getting more and more calls. Maybe as the expansion slows down, slurry storage is obviously the big buzzword. People that might have been at 16 weeks have to go to 20 to 24 and so on. So are you seeing an increase in inquiries, say, in general? Yeah,
definitely in the last 6 months there's a lot of increase. In the previous 2 years, maybe during the early parts of COVID and everything, the inquiries had dropped a good bit, and mainly that was due to the fears about the covering of lagoons and everything. But in the last 6 months the inquiry levels have really started to rise again, and it's guys looking for storage because they're under pressure with their current facilities, and that's mainly the gist of what the nature of them are at the moment.
Yeah, and so from your base in Waterford, are you covering the country? Or?
We cover the country, all 32 counties, and we even do lagoons in the UK as well. But most of our work is, if you draw a straight line across from maybe Louth across to Galway, below that is where most of the lagoons get put in.
Yeah, and it's probably no harm for farmers who are interested to know, like, it is a kind of a seasonal job. Like, you probably need to be talking to people out of season to be prepared for the season. Could you just
Yeah, people really need to be talking to us early in the year, particularly because they have to go through the planning process, and that'll take 3 months before that's all going well before they can actually get the digger on the ground. So if they're looking at doing the job in the summertime when the weather is dry, they want to be getting going, early in the year. And then most lagoons will take, this one for example takes about 5 weeks to do start to finish, and most lagoons even up to 1.5 million gallons will be done in that similar time frame. So they want to allow for that, and then with a view to when their animals are coming back in for the winter, that they have their lagoon up and running by that time.
Okay. So you have a website where you can see all your...
Yeah, everything is on Geoline.ie, and there's an agricultural section on that there, and that should take you through step-by-step process of it.
Okay, very good. And thanks for your time here today.
You're welcome. Thank you.